Now let us discuss this problem. So before discussing this, I can discuss one small theory. Let us say I have a slab and the thickness of this slab is T. So we have a slab of thickness T. I am basically making this slab is slightly exaggerated and refractive index of this slab is mu. And there is a object that is kept here. This is object. Let us say this object is kept at a distance x from this end. So from the rear, this left end you can say. Now what is my target is? My target is to find if the rays come from this surface, what is the apparent shift of the position of O? So what is the apparent shift? So I am interested in apparent shift this time. So what is the apparent shift? Now to solve this one, what we will do is we will again apply mu2 minus mu1 by r. Now in this case r is infinite, so I can now simply write mu2 by v minus mu1 by u is equals to 0. Let us apply this equation for this surface. So let us say surface, left surface. So if I apply this formula for left surface, what I will write? Let us say mu2 is mu, so mu, and mu1 is air, and that is 1 refractive index. I can take this one. So air is 1, so minus mu2 by v I have to find, minus 1 by u. What is the u? This distance. So this is my pole. So from here I have a distance x, but I am going this side and the ray is coming this direction. So this is my minus x. So this is equals to 0. So if I solve this one, I will have mu by v is equals to minus 1 by x. So this implies v is equals to minus x by mu. That is, if mu is greater than 1, so v is less than x. So now I can say v is minus x by mu. Since mu is generally greater than 1, so I can say v is less than x. Are you getting or not? So my image is formed somewhere here. So this distance are measured from the pole. So my image is formed due to the first surface, due to the left surface. Let us call this is my image I1. Are you getting or not? Now this ray, so this length is basically lengthwise x by mu. Now let us consider the refraction at the second surface. So refraction at the second surface, that is the right surface in this case, I will apply the same formula again. Mu2 by mu2 by v, mu2 in this case is 1 because ray is going from slab to the air, so mu2 is 1 by v, I have to find v, minus mu2 by u, mu1 by u, mu1 is mu, and what is u? This distance from the pole. So what is the distance? This distance is t and this distance is x by mu, so the total distance is t plus x by mu. So this distance is t plus x by mu is equals to 0 because radius of curvature is infinite, so 1 by v. I have to plug a minus sign also because this object is this side and ray is going in this direction, so apply the sign convention. So this is again negative, so I will have 1 by v is equals to mu divided by t plus x by mu. Are you getting or not? So what is the v in this case? You can solve for v. So let us solve for v. You will have, this is basically I have done one mistake in this case. b by v is equals to, so this is x mu, not x by mu, so this is x into mu. So let us say wherever I have x, I have to place x mu, not x by mu, so this is mu x, and that is the problem. So I have to have x mu. So let us plug this value x into mu, and here also I will have x into mu. Are you getting? So what is the value of v? Now v is negative, minus minus plus, if this go this side, so I will have v is equals to, this is t plus x mu divided by mu. So this is simply x plus t by mu. So now the second image, that is V2, is formed at a distance of x plus t by mu, and now this distance is from the second surface. So x plus t by mu. From here, this image is somewhere here. This distance is, now I know this distance is x plus t by mu. So one can ask, what is the apparent shift? Initial object is here and now object is here. What is the apparent shift? Can you calculate this apparent shift? You can calculate this apparent shift. This distance is x, and now this distance is x plus t by mu minus t. What is this distance? Let us call this point is A. So this distance is, if this distance is x plus t by mu, then this distance is x plus t by mu minus t. So what is this distance? This distance is x minus, so this distance I can write x minus x plus t by mu minus t. Are you getting or not? Because this distance is x plus t by mu minus x. So this distance I to A is equals to x plus t by mu minus t. Are you getting? So this is what? So I can say this is the apparent shift. Apparent shift is x goes, and you will have t minus t by mu. So in this case, apparent shift is, again same thing, apparent shift is t into 1 minus 1 by mu. This formula is same as we derived generally in the textbooks, but now it's always good to derive from the initial. So t is 6 centimeters. So in this problem t is 6 centimeters. So I have a slab of thickness 6 centimeter and refractive index is 2. So this is 6, 1 minus 1 by 2. So we will have 3 centimeter. So in this case, so if you put a slab of 6 centimeter, refractiveness 2, you will have a apparent shift is 3 centimeter, and now image will shift towards the slab side. So 3 centimeter is the shift, and it will shift towards slab side. It will shift towards slab side. Now let us discuss this problem. So we have a convex mirror. So this mirror I have, and now, and another important point, this shift is independent from x. The apparent shift is independent from x. So anywhere you can put the glass slab, you will have the same shift. Now let us say you have the object somewhere here, and there you have a glass slab of 6 centimeter thickness, and we are interested in what is the final image, and this distance is given to you 33 meter, and the focal length of also 33 centimeter. So this is not 33 meter, so this is basically 33 centimeter, and the focal length is radius of curvature divided by 2, that is 20 centimeter. So focal length is 20 centimeter in this case. Now what will happen if place this slab? So now this distance is 33 centimeter. Now due to this, there is an image that is formed. This image I have called I2, because refraction through this is I1 and refraction through this is I2, and this shift this side, and how much? 3 centimeter. So apparent shift is 3 centimeter. So what is this distance from its pole to image? What is this distance? So 30 centimeter. Now you see, for this mirror, this is the object. I2 is the object for convex mirror. I2 is object. Are you getting? So if I2 is object, I can apply 1 by u plus 1 by v is equals to 1 by f. So let us go fast. 1 by u plus 1 by v is equals to 1 by f. Now in this case, u is this side, so this is negative, vi does not know, and f is positive. So let us find v. So 1 by v is equals to 1 by f, and this goes this side, this plus 1 by u. And f is 20 centimeter, so 1 by 20 plus 1 by u is 30 centimeter. So this is 1 by v, so 63 plus 2, so this is 5 by 60, 1 by 12, so v is 12 centimeter. So in this case v is basically 12 centimeter. V is 12 centimeter. We can calculate now, if I know the v, that is the 12 centimeter. This means we can plot this one. What we will have, so let us say, so you have, this is the mirror and now v is 12. Now v is positive, this means image is this side. So your image, let us say due to this, let us call this I3, is somewhere here, and this distance is 12 centimeter. Are you getting or not? Now the image, what is happening? So rays coming, and this ray, let us say paraxial rays, these are the paraxial rays, this ray is coming from here. So this is the my I2, this is my object, so this paraxial ray is coming. Are you getting? Now once this paraxial ray goes here, this will be reflected back in this direction. So now let us say this reflects back in this direction, so this ray goes in this direction, so it looks like this is coming from here. So this is my I3, but now this ray is going here, will again be reflected. Are you getting or not? So this is due to the, if this surface is bigger, there is again reflection or refraction, apparent shift. Are you getting or not? And due to this, there is apparent shift of 3 centimeter. Now this image is here and apparent shift towards the slab, so this will look something like this side. So this image is I3. Now a new image will be formed. This image will be I4. So this image will be I4, and now this shift will be basically 3 centimeter, because apparent shift due to this slab is 3 centimeter. So you see, we have to calculate what is the distance of object O and I3, I4. What is distance between object distance? What is this distance? 12 centimeter. What is this distance? 9 centimeter. So this, let us say pole, what is the distance between pole and I4? That is the 12 minus 3. So distance between pole and I4, this is equals to 12 minus 3, because apparent shift is 3 centimeter. So this is 9 centimeter. Question asks, what is the total distance between object and final image? So the total distance OP is 33 and PO is 9. So 33 plus 9, that is 42. Are you getting or not? So distance between final image and object, distance between the final image, and object, and this is equals to 33 plus 9, that is basically equals to 42 centimeter. Are you getting? So quite interesting. You see, first time there is a refraction. There are two refraction at this surface, this surface and this surface. So due to these two combined is here I2. Let us say again, you will have, due to this reflection, you will have image this. Now again you will have a refraction due to these two surfaces, and due to these two surfaces there is a shift of 3 centimeter, and we have already saved this shift towards the slab side. So you can remember this result. If the slab has refractive index smaller, this shift towards the slab side. If this slab has refractive index lesser than the medium, in that case it will shift away from the slab.